Hello, everybody. This is Chris Riley from DevOps.com, and I'm excited to be the host of today's webinar on 3 reasons to pick a time series platform for monitoring your DevOps-driven containerized apps. We're going to be starting here in just a few minutes. I'm just going to give it a few more minutes here before we kick it off. Just so you know, you can hear us, but we can't hear you. So if you have any questions, please type them in the question box. And also throughout the webinar, as you think of questions, make sure to jot them down, and we will record those for the Q&A session at the end. So sit tight. We're going to begin in just a few minutes here. All right. Well, thank you everybody for joining us today for a presentation given by Navdeep of Influx Data on the 3 reasons why you should pick a time series platform for monitoring your DevOps-driven containerized apps. Before we begin, I want to just go over some housekeeping things. First is that you can hear us, but we can't hear you. So if you have any questions, please type them in the question dialog. Any that are logistics related, we'll try to get to those as quickly as possible. And then the others we'll record at the end of the webinar for our Q&A session, and we'll leave about 15 minutes for that. The other thing is make sure you stay for the entire webinar, because at the very end, we're going to be giving away 5 $50 Amazon gift cards, and we'll announce those just after the Q&A session. My name is Chris Riley. I am from DevOps.com, and I'm excited to introduce you to Navdeep to cover this really important topic as it relates to building and monitoring modern applications. So Navdeep, take it away.
Thank you so much, Chris. Very excited to be here. And today we are going to talk about some of the trends in the DevOps area, and also when it comes to containerizing existing applications or new applications, and then talk a little bit about Kubernetes as well. That is one of the hottest topics these days. So the goal here is to show you some of the newer ways of monitoring all these, the DevOps, tool chains, the containers, and the Kubernetes orchestrations using the time series platforms. All right, so let's get started. All right. So we see a number of trends in the market today. Companies are adopting DevOps. It's not a new thing. It's been going on for more than a decade. But more and more companies are now discovering benefits of DevOps. And as they are trying to adopt DevOps, containers like Docker become an obvious choice. And then when you're doing Docker and you're looking for web scale, Kubernetes becomes an automatic choice there as well. We see very little adoption for Swarm, and Kubernetes is perhaps 10 times or even more popular than Docker Swarm. So for containerized applications, Docker is probably the #1 standard out there, and for orchestration, Kubernetes is winning the battle. So companies are building low-code IoT, process-driven microservices apps, a lot of flavors of application architecture. And these are all modern application architecture styles, depending upon how technical your IT team is, how how much overhead you're looking for, how much maintenance you want to perform. So people are picking up different type of stacks to build their applications on. But one thing is common across all these stacks. These modern stacks need better monitoring. And the reason we say you need better monitoring is as you adopt these application architectures, you are now monitoring DevOps tool chains. You are monitoring containerized application. Your application is not hosted on that Java server anymore. Now it's sitting on top of a server in a container. And then you are monitoring the health of the containers themselves. And additionally, if you are using Kubernetes, you have to monitor the health of Kubernetes clusters, nodes, pods. So the whole scenario has just become a lot more complex. And most of the companies have historically not dealt with that type of complexity. And same thing is true for the monitoring technologies as well. So the existing monitoring technologies are failing when it comes to monitoring modern application architectures, containers, and the Kubernetes clusters. So Kubernetes adoption is growing globally. And there's a reason I put this slide and not about Docker. I think we all know that Docker is the #1 container technology out there. But jury is still out about Kubernetes. Some people think it's too complex. Some developers love it. Some developers think it's cumbersome. But if you look at the growth of Kubernetes, it's just phenomenal. Kubernetes has become a truly global phenomena, and some of these stats will, try to highlight that point for you. The Kubernetes meetups worldwide have attracted 166,000 members in 200 plus cities in 60 plus countries. That is a lot of traction for an open source product out there. And the picture on the right hand shows Kubernetes versus Cloud Foundry versus Apache Mesos and Docker Swarm. And you can just see that Kubernetes is much more popular than the other three combined. And then if you look at their open source traction, they have 73,000 commits, 400 releases, almost 2,500 contributors, and it is one of the top 2 start Go projects. So Kubernetes is up there. And now the title of this session was 3 reasons why you need better monitoring when you're doing things like DevOps, Docker, Kubernetes. The whole reason is that legacy monitoring doesn't hold up. Legacy monitoring cannot provide these 3 things. These are the 3 reasons. One is uptime, then the second one is complexity, and the third one is scale. So high uptime requirements, they require sub-second visibility into the architectures. So your Docker has to be up, the 5 nines, and Kubernetes is up all the time. Your application needs to be up all the time. These significant uptime requirements require sub-second visibility into what's going on across your containers, across your Kubernetes nodes and pods. And the legacy monitoring typically monitors at a 5-second, 15-second, or even 30-second interval. So this sub-second thing is very new to these legacy monitoring tools, and most of these tools just cannot perform and operate at that level. And the second point here is complexity. As you have seen from some of the past slides, the application architecture has evolved. There are more layers in the architecture. All the layers are performing a very specific function there. Containers are enabling you to start up the application in milliseconds. And then the Kubernetes is helping you with auto scaling the application across different clusters. Now, if you look at the number of components involved in getting an application up and ready, combine the dozen or more DevOps toolchain pieces, the Chef, Puppet, and everything else, and now you got at least 20 to 30 moving pieces for just one application. That's a whole lot of complexity, and the legacy monitoring just simply cannot monitor that level of cross-domain applications. It cannot give you that cross-domain visibility into those. The third point is scale. Legacy systems cannot handle volumes of the metrics that are being generated because all these components, the 20 or 30 moving pieces, they're now spitting out hundreds of thousands or even more metrics and events per second. And legacy monitoring cannot ingest, cannot process, cannot query that level of volume. So we'll go into a lot more detail, but I just wanted to set the stage by showing you the three reasons why legacy monitoring doesn't cut it anymore. I apologize for jumping the slides. My keyboard for some reason is not working with this go to meeting, and I'm using mouse and I scroll too fast. All right, so let's talk about emergence of time series platforms, right? So just to set the stage, we talked about the new application architecture styles, and we also talked about the three reasons they are not cutting it anymore. And now let's talk about time series platforms and let's see why they are providing the value where the legacy monitoring is failing. So time series is a new concept. The new workloads of metrics and events are growing exponentially. One of the reasons is explosion of connected things. The IoT devices, the machines, the machine to machine interactions, they are just growing exponentially. So we see in the market today an explosion of data. And all this data falls into either the metric category or the events category. And we will also distinguish between the two in a few seconds. So just bear with me. And the second point is instrumentation of the virtual world. So we see a lot of instrumentation. We see a lot of machines controlling data driving things. Even the good example of automated vehicles. More and more instrumentation, whether it is smart home, smart grid, it is just taking over the world. And that is kicking off a lot of data. And now the third angle is the consolidation of metrics and events data. So consolidation of metrics and events data into one system is sort of new. Typically, these metrics, which have been the system stats, and events, which are the user-driven stats, are they were handled separately. But now we see platforms which are handling both the users, the human aspect, and also the IoT aspect together. They need consolidation of metrics and events data in one platform. A good example will be if you're an energy company and you have sensors, and now with those sensors, you also have that data feeds going into a system where a human is controlling or taking an action on top of those metrics. So all that intelligence now needs to reside in one system. All right, so why are these metrics and events unique, and how do they conform, or how do they play in the time series space? So let's start off by saying both metrics and events are timestamp data. Both metrics and events are essentially time series data. So time series data to us comes in two flavors: metrics, which are regular, and events, which are irregular. So let me give you a few examples there. So your CPU of your laptop or your server, they emit a few metrics every millisecond, right? The CPU cycle time, how hot the CPU is, how much energy it's consuming. All these stats are available, and you can go and check those stats. For a Windows machine, you can just put Control Alt Delete, go to Task Manager, and these are essentially metrics. These are the system metrics. You're looking at the memory consumption, how much memory is consumed right now, how much memory is available, right? So these are pretty regular stats emitted by your motherboard, by your CPU every few milliseconds. And then there are irregular periods when a human being has clicked on the order button, or a machine has started, when somebody started the machine by pushing a button. So you're tracking that event, right? Event is when something happened due to somebody or a machine or a human taking an action. Usually metrics are a lot more in volume than events, but if you combine these two, they both represent huge volumes of data. And that's the reason time series is so different, because the volume is so huge, you have to ingest large volumes of metrics and events per second. And you also need to enable real-time queries on large data sets. And I will show you some data sets today as well. I'm trying to make this this session valuable to the technical audience. So there are a lot of technology slides and also some data samples as well. Just stay tuned here. So the third thing here is time series requires eviction and transformation of data and downsampling of high precision data as well. And then finally, storage optimization and compression. Now, when the time series data, the millions of bytes coming out every second, they are stored, you need optimization. Otherwise, the storage cost and storage manageability becomes very difficult. So time series attributes are large volumes, high ingest rates, large number of real-time queries, rapid eviction of data, downsampling, and storage optimization and compression. So this is why time series is so different. And time series data is growing so rapidly that we think it is a new architectural approach. Historically, if you look at the database trends, Oracle stores relational orders, order lines, the customer, which customer bought which orders, when did they buy it. So all that relational data used by SQL, you can query it by SQL, PL SQL, different versions of SQL. That is the RDBMS. And then we have search type systems like Splunk, which store logs, web pages, and you can search across a wide range of data. And then we have finally big data, which allows you to store any type of data, whether it's a JSON object or a document or a multimedia file. The volume and variety is just huge. So in addition to three mainstream sources, this is the emerging data source today, time series data sources, which allow metrics and events. This is the fastest growing database segment today. And this is also in terms of volumes and popularity. Metrics and events are growing far greater than any other type of data today. All right, so what is Influx Data? Before we go into the product side and talk about deployment architectures and technology capabilities, let me just set the stage by saying we deliver the modern engine for metrics and events, essentially time series data. So Influx Data is an engine for metrics and events. All right, and this is the famous tech stack. Influx Data's platform, we have four components: Telegraph, InfluxDB, Chronograph, and Capacitor. So TICK, the tech stack. And we will go into a lot more detail for each one of these four components. So I will just stop this slide here, and then we will start off on the next slide, talk about Telegraph, and then we will talk about InfluxDB, then Capacitor, and then Chronograph. And then we will show how they come together to give you the #1 platform for time series data today. And then we will talk about some of the use cases and how, if you're doing Docker, Kubernetes, or DevOps tool chains, how you can use this stack to monitor everything that you have in your IT ecosystem today. All right, so this is the first slide for the tech stack, and it talks about the Telegraph agent, which we have for collecting and reporting metrics and events. So Telegraph is one of our most popular, most adopted plugin for ingesting metrics and events. So plugin driven, the concept is that Telegraph has four types of distinct plugins to collect and report metrics, right? So if you look at the whole stack, the idea is to ingest, store, process, and display metrics and events so that you can do whatever you want, whether it is monitoring, whether it is analytics, whether you're just tracking a bunch of metrics from, 10 servers or 10,000 servers or a million servers. We can handle wide range of data, wide range of metrics. And the first step is ingesting. So Telegraph has four types of plugins to get data, and that is where the input plugins come in. Input plugins collect metrics from systems, services, or third-party APIs. And the second type of plugins is processor plugins. So once you have basically ingested the data, you want to transform, decorate the data, or put in some filter metrics, right? You want to convert US to USA, those kind of things. So those kind of processor plugins are available today as well. And then the third type of plugins, we call them the aggregator plugins. So you can do some basic math. Let's say you're ingesting the data and you want to do some basic math on top of those metrics. So before you send them over to InfluxDB for storage, you can do some aggregation beforehand. And finally, the output plugins. Output plugins, they write metrics to various destinations. Obviously, one of the destination is InfluxDB. And let's say you're running multiple flavors of InfluxDB, InfluxDB 1.6.7, and the most recent 2.0 alpha. You can have Telegraph have multiple output plugins where Telegraph is writing to more than one data store. Now, the beautiful thing is the number of plugins today exceeds 200, and we keep adding new plugins virtually every week. So this week, we have added around 9 plugins, and these plugins include some of the very useful plugins if you're using Google Cloud. Google Cloud PubSub and Google Stackdriver plugins are now available. And also for Amazon users, the Kinesis, and for Kubernetes user, Kube Inventory plugins are now available as well. Now, so no matter which ecosystem you work in, whether you're an AWS customer or a Google customer or an Azure customer, or whether you're trying to monitor networks or you're trying to monitor Docker, DevOps, we have you covered. All these plugins, they span a wide spectrum of technology to give you monitoring capabilities for everything. And Telegraph is so popular. It is the most popular metric ingest tool, product, plugin. You can call it many different names. It is the most popular capability out there of its kind. All right, so moving on to InfluxDB. InfluxDB is, as the company name stands out, Influx Data. We are famous for InfluxDB. This is our core product. It is a modern, built from scratch, purpose-built time series database. It is not a bolt-on on an RDBMS. It's not a bolt-on on top of big data. So you will not need 2 months to configure it, install it. It is purpose-built. You right-click, you download, right-click, and install it in seconds. It is built to handle high write and query load. So high ingest, high write. It can store terabytes of data. It can do sharding. It is purpose-built for time series, for high performance, and written in Go. It is enabling DevOps monitoring, application monitoring, IoT sensor data, and real-time analytics, and many, many other use cases as well. So let's say you are trying to get metrics from your application, then you're trying to get metrics from your DevOps tool chain, and then you're trying to get metrics from Docker and also from Kubernetes. And within Kubernetes, you have metrics coming in from pods and nodes and master. And all these different metrics can go into InfluxDB. So let's say you have 200,000 or a million points that you are trying to read or scrape or ingest per second or at a sub-second level. This provides that high read, high query, high ingest, high query workloads for time series. So everything in time series is grand. Time series doesn't deal with 10 orders per minute or 20 orders or 500 orders per minute. Time series data requirements are huge. You have to handle hundreds of thousands, or in some cases, millions of records per second. And InfluxDB is purpose-built to do that. And the second thing is very important. A lot of customers that are using us on the cloud, they love us because they see the compression we provide. So we manage the space in the cloud really well. So if you are storing 4 terabytes of data, we can downsample it, we can compress it, we can bring it to a fraction of the original data size so that you're not paying for that kind of data. And some of these capabilities you can buy from your cloud provider as well. But what happens is cloud providers are incentivized to store uncompressed data. So we actually want our customers to save a lot of money. So we love compression and we want to delete any unwanted data. So we provide very sophisticated capabilities to delete unwanted data and also to compress it. The data that you want resides on the disk in a very extremely efficient compressed format so that you are not paying for data storage that much. And then on top of that, we offer a SQL-like query language for interacting with data. It is called InfluxQL. And we recently launched a new query language called Flux, which is more of a scripting language. So no matter what your needs are, where you're coming from a data standpoint, from a query standpoint, we have you covered. Right? Going to the next slide. This is an example of metric. So we have talked about metrics and events, and I know this can be confusing, especially if you're not familiar with the concept. And this slide shows you a little bit of what a metric looks like, right? So the first example is your response time for GET. And the second one is just a weather sampling record, right? So depending upon which field you are in, whether you are working with IoT sensors, whether you're working with energy equipment or home automation, or even in automobiles, you will find different sensors. They produce different type of outputs. But what Telegraph does is Telegraph then takes those data sources, the sources for metrics, and then it converts them into a line protocol. And line protocol is simple, it's a read. So in the first example here, we are reading the response time, method is get, precision is milliseconds, and then there's a value. And in the second example, we have weather, location is US Midwest, summer, and then you can go to a lot more granularity. You can have addresses. So line protocol is the simplest and the fastest way to get metrics into the Influx DB data store. Okay. So fourth, or rather the third part is capacitor. So tick is T-I-C-K, but I have the slides in reverse because I want to spend a little bit more time talking about chronograph. So let's talk about capacitor first. Capacitor is our real-time streaming data processing engine. And the benefit of capacitor is that you have a lot of information coming in the form of metrics and events via Telegraph into InfluxDB. Now, sometimes you need to be able to intercept those streams and also apply some logic to it so that you can trigger some alerts, or you can do another action. You can take action on what was going on. So Capacitor is the technology that handles that. It can process both stream and bash data from InfluxDB, and then it can apply a logic. So you can process alerts with dynamic thresholds. You can configure an alert saying that for server A, if the memory goes down below 10% available, then send an alert. For server B, if the memory goes below 15%, then send an alert. So you can set up those different dynamic thresholds for different types of metrics. And then you can also detect metrics for patterns. If all your servers are showing memory out or running out of memory, what's going on? And then you can also compute statistical anomalies. So based on the data you just ingested, if you want to perform any statistical queries on top of that, or you want to take specific actions based on alerts such as dynamic load rebalancing, and or perhaps you have HipChat, Opsgenie, Alerta, Sensu, PagerDuty, Slack, or any other type of company-wide alerting mechanism that you use, it integrates with all of them. So essentially, your alerting mechanism, which sits on top of InfluxDB, and alerts you in real time based on what you use in the company. For example, let's say you use Slack, and there's a Slack channel for system alerts, and users are complaining that the website is not performing, and you just go to the channel and you say, oh yeah, I know why it's not performing, because there are 5 servers are running low on the memory, and this looks like some capacity issues going on in the infrastructure there. And finally, we talk about Chronograph. Chronograph is the complete interface for the Influx Data platform. So Chronograph performs many functions. In the simplest words, I can say it is the UI. And as part of the UI, it does both dashboarding, configuration, and many other things. So the complete interface for the platform, and not only Kubernetes, we are now trying to add more and more pre-canned dashboards. Depending upon where you're coming from, you will need different types of dashboards. But in Chronograph, we are starting to include out-of-the-box dashboards for key features. And starting off with Kubernetes, we have different dashboards available. And I think I have a sample on the next slide as well. So Chronograph gives you high-performance data store for the timestamp data. And you can explore the data, you can write queries, you can store your queries, you can dashboard your queries, and you can essentially view data as it goes into InfluxDB. So it is your window into InfluxDB, but much more than that. So let's take a quick look at Chronograph. All right, so Chronograph has different dashboards. You can visualize that information, and it's a pretty simple, very powerful UI. And you can configure your InfluxDB using Chronograph. You can create new dashboards. You can share dashboards from each other. You can also visualize a lot of the information that is stored in the InfluxDB as well. And the way you do it is you basically use the Data Explorer. And using the Data Explorer, you pick what data you want, and then you can pick a layout, and then you can just visualize the data in 2 or 3 simple steps. You can also plug in your templates and also your libraries, and then you can say, I want to use some of these libraries to apply some logic before I do this visualization. You can certainly do that. And then finally, if you are interested in alerting and automation, it can help you configure some of those alerts as well. So it's very user-friendly, one of our most popular projects out there, and it gives you so much value and works really well. And we have done some major enhancements on the Chronograph, and the usage of Chronograph is just going through the roof right now. All right, so that was a lot about our technology. Now let's talk about how we monitor things like Docker, DevOps, and Kubernetes. So I will focus here on Kubernetes and Docker. DevOps is fairly easy to do as well. There is no specific deployment architecture depending upon the DevOps toolchain and the technologies that you have in that toolchain. You can start using Telegraph plugins, have them stream those metrics into the InfluxDB data store, and you can go from there. But for Kubernetes, it becomes a little bit more challenging because Kubernetes is fairly new. There are different deployment patterns, and it can become really confusing because some of the customers use Prometheus and they think Prometheus can solve all the problems in the world for them, which is not essentially true. So my goal from these next 3 or 4 slides is to talk about Kubernetes, Docker, and how Influx can monitor. How do you deploy them? What are the different deployment architectures? And also, what is the value we provide on top of Prometheus? All right, so let's get started. In this picture, you see the master node on the left-hand side. And then you see the node and the 2 pods on the right-hand side. Now, Telegraph, which is the key component for scraping the metrics and events, is essentially deployed in two ways, as a daemon set and also as a sidecar. And the reason we have shown you, you can pick one of these depending upon your needs. The benefit is if you deploy using sidecar, you get a lot of application level granularity. Let's say you have an application which is deployed in Docker and you choose to deploy Telegraph as a sidecar. Now, as a sidecar, Telegraph can do a lot of reads on the application. So if you are interested in how many gets and response times, user interactions, how many users are putting how many things into the cart, and how many times they are emptying the cart, how many users are abandoning the cart. So those type of user stats, how many time they are, how many seconds they're spending per page, those kind of things are very relevant for application monitoring. And then for that, deploying Telegraph as a sidecar makes a lot of sense. But on the other hand, if you're more interested in pod stats and also the node stats, then daemon set is probably a better option. Daemon set is easier, but it will not give you that many metrics that the sidecar will give you. And if you're monitoring application versus the Kubernetes nodes, then Telegraph as a sidecar for application monitoring is a better option. And if you're not interested in application monitoring at all, you have other tools, then you can just use Telegraph as a daemon set on the Kubernetes nodes. So you can get consistent metrics out. Telegraph will bring your application metrics as well as your node metrics and pod metrics out. So in your data store, which is Influx DB, you get all the metrics from all your data sources, the app, the node, the pod, in the same format. And then you can also implement push style metrics for the whole cluster. Now, you may call them events or push style metrics, but essentially, InfluxDB with Telegraph can handle both push and pull when it comes to metrics. And for companies who use Kafka or any other messaging, the push style is very popular because it fits in very well with the message queues. So you can get both push and pull with InfluxDB. So consistency in metrics, long-term storage, high availability, and you enable push style metrics. There are huge advantages of InfluxDB in monitoring Kubernetes and Docker. And the second option here is working with Prometheus. So sometimes we encounter customers who adopted Kubernetes and then off the bat, they started with the Prometheus project as well. And then if they are heavily invested in Prometheus, our guidance is to use Telegraph alongside Prometheus. Prometheus primarily is for pull style metrics, and it doesn't do long-term storage or high availability. And there are also some security issues as well because it's not a fully featured open source project. And there's no commercial entity behind Prometheus, so that building security and tooling around it becomes a bit of a challenge. But if you're heavily invested in Prometheus, you can start using Telegraph, and you can build on your investment in Prometheus by having Prometheus and Telegraph sitting side by side. Telegraph will scrape Prometheus endpoints. So the beautiful thing is Telegraph can scrape 200 plus sources, and it can also scrape Prometheus endpoints. So you get the same information from the Prometheus endpoints into both Prometheus and Telegraph. And then, on top of that, Telegraph will support push style metrics as well. And then InfluxDB becomes your source for long-term storage, high availability, and you complement Prometheus's pull style with Influx's push style. So you get best of both the worlds. And if you don't want to use Prometheus, as in the last picture, you can get both push and pull from Influx as well. All right, so if you have questions, if you're a Prometheus user, I have Prometheus, why do I need InfluxDB? This is why. You can monitor both Kubernetes and non-Kubernetes sources. You can do clustering, high availability. You can have security and alerting. You can get metrics, both pull and events, which are push style. and also preserve your investment in Prometheus. So, Prometheus comes embedded with Kubernetes, and it's a good starting point. But we see a lot of large companies, it doesn't meet the long-term storage and compliance needs, especially if you're in a healthcare or some other industry which has to store data for 5+ years. Banking and healthcare come to my mind, and Prometheus just cannot do that. So it is good enough to get started, but it is not enough for today's modern monitoring needs. So uh, just my last slide on the Kubernetes topic, and then we will talk a little bit about Influx as well. So if you're getting started with Kubernetes and you want to know what do we have specific to Kubernetes, we have launched Helm charts, which can deploy Telegraph as a daemon set to start monitoring nodes, pods, and container. And then we have service operators, which simplify deployment and backup of our database. And then we also have HashiCorp's Terraform modules, which allow deployment of Influx DB Enterprise on AWS. So I have links to documentation and the landing page here as well. But the point here is, if you want a single platform for metrics and events in your company, for monitoring, for dashboarding, then Prometheus will not deliver it. Influx Data works with both Kubernetes and non-Kubernetes sources to deliver full stack monitoring. So whether it is a legacy system, it is a queuing system, it is a networking system, it is DevOps, Kubernetes, Docker, we can monitor everything and provide you the full stack monitoring. So I wouldn't spend a lot of time, maybe next 4 to 5 minutes about Influx Data, so that you are familiar with our company and our offerings as well. Our platform strategy is to be the platform of choice for all metrics and events workloads. That means IoT data, infrastructure metrics, business metrics, events, user events, no matter what it is, all metrics and events come into InfluxDB, and then they are stored in InfluxDB to provide monitoring, analytics, tracing, and machine learning on top. And then from an open source project, we are very, very successful. We are very lucky to have over 15,000 Git stars in less than, or well, a little over 5 years now. And if you download our database, we have a phone home feature, which we openly encourage you to disable if it violates your company's security policy. But there are more than 188,000 database users today, which have enabled the phone home user, and so that we know how many people at a given time are using our database. And the actual number is a lot more, because more than 50% of our customer base, they disable the phone home feature for security reasons. They don't want anything going out of the firewall without their knowledge. It's very easy to disable. So we think it's the usage of InfluxDB is in millions. We are also growing as per third parties. The visual that you see on the right hand side is by a third party called DB Engines, and DB Engines tracks the growth of different databases, and you will see that we are growing very well. This is a little bit of a competitive growth, how we are growing compared to other types of databases. So you can see the relational databases are not growing at all. They're actually declining. Search is growing, and the graph databases are growing. And then the fastest growing on the left-hand side in the last 24 months is the time series databases. And then on the right-hand side, within the time series databases, you can see that InfluxDB is more popular than all the other time series databases combined. And even still, it'll probably be a little bit more popular than that. So that is a little bit about us. And now let's talk a little bit about our customers. We are extremely lucky to have companies like SAP, Bbox, Wayfair, Coupa, and New Voice Media. We have around 500 paying customers, and we have, as I mentioned earlier, we have millions of open source users. And these companies are doing a wide range of things, from IoT to DevOps monitoring to Docker and Kubernetes monitoring. And it is just extremely exciting to see how they're finding innovative uses of our platform. So this is a bit more into how we categorize our customer base. At the top is real-time analytics, then we have IoT monitoring, and then we have infrastructure application and business process monitoring. Um, and we are super lucky to have some of the big logos, but in addition to showing you the logos, I want to talk a little bit about how they use us. And I've selected a few use cases. They're all different so that you get a good understanding of what the use case in your company may be for which you want to download and start using InfluxDB. So SAP is a big company, many different business divisions. One of the business division is SAP Ariba, which is their B2B hub. And for the Arriba platform, they provide a lot of visualization, alerting, monitoring, and they use InfluxDB as the primary data store to collect metrics and events for Ariba. So this is a quote from the VP of Global Cloud Infrastructure at Arriba, and how they use Influx Data. Siemens, on the other hand, is again similarly have many businesses, but this is the IoT use case. They have wind and gas turbines, and what they provide is as a service. They allow their customers to monitor the health, usage, and performance of these turbines, and they assimilate the data. The data goes from turbines into Influx Data, and then it is exposed to the different customers using the REST API. So it's a very IoT-driven use case. And then e-commerce, Wayfair is using Influx Data to monitor system metrics and events. The goal is to marry these with business process events and provide better business insights and comparative advantage. So Wayfair story is pretty well documented, and they also host our meetup in the Boston area. So if you just look up Wayfair replacement graphite with InfluxDB, you will find the URL and you can read their story in detail. If you are using legacy monitoring technologies today, I would highly encourage you to read the story. It'll give you some ideas on how you can improve and provide granular visibility into what's going on into your infrastructure to your stakeholders today. And then finally, two summary slides I have is, after this, if you don't remember Influx, keep these things in mind. Influx is modern engine for metrics and events. If not today, if tomorrow there's a need for metrics and events, think about Influx. Our focus is developers and builders, and our biggest difference is that we are purpose-built. We don't do 5 types of databases. We only do one type of database, which is really easy to install and configure. We deliver what we call is fastest time to awesome. And that means you can achieve the wow in the shortest time. Within 30 minutes, you should be up running and be extremely delighted. And real actions in real time, right? From all the way from fast ingest to fast query downsampling, we are proud to deliver real action in real time. And as I mentioned earlier, we have 188,000 unique active deployments that we know of, and millions of others, and around 450 plus customers. From a next step standpoint, please visit our website, influxdata.com, for more information and tons of more customer case studies, and download our products. InfluxDB, you can download the OSS. We also have a 14-day trial of our enterprise version and also a trial of our cloud version. But OSS is where most of the folks get started. Within the OSS, we have a stable 1.x line, and we just launched our 2.0 alpha, which is a game changer platform. You can download either one from our website or GitHub. And then we have 3 flavors: OSS, Enterprise, or Cloud. You can try 1, 2, or all 3. Depends upon what you need, whether you are a startup which needs only cloud, or you're a large company and you have a big data center and you would rather download the OSS and check it out. It's totally up to you. Interact and reach out, right? So once you download, don't be shy, reach out. We have forums, we have GitHub, or you can just contact us. On our website, there are 2 ways to contact us. There's a bot, there's an automatic bot you can talk to, or you can just click on the contact us button and send us an email. So that's it for today.
Great. Well, thanks, Navdeep. I always find it very interesting how modern types of applications or new types of applications and modern delivery methods end up impacting what people need to consider on their delivery chains. So this is fantastic. Well, we have some time for some questions. If you have any questions, please post them in the question dialogue. We're not going to be able to get to all the questions, but Influx can follow up on the ones that the specific ones about Influx that haven't been answered. And also, right after the questions, we're going to do the giveaway for the 5 $50 Amazon gift cards. So the first question actually comes from Eric, and it relates to your last slide, is how does a company choose when they're going to use open source enterprise versus cloud technology on the tech stack?
Yeah, so good question. The simple answer is it's based on your preference. Our tool set our products have similar capabilities. So a lot of companies are just happy with our open source because they have data centers. They don't want to deploy. They don't want their data to reside in somebody else's cloud. So they just deploy the OSS or the enterprise version in their data centers. And from a process standpoint, I would say we have seen normally there's a gradual progression from OSS, from a pilot, and then they start using OSS for a project. Then they start using it at an enterprise level, and then they realize they need to have Influx support, so they just switch to the enterprise version. On the other hand, a lot of startups with IoT kind of background, they just start off with the cloud. They have no servers, they are lean, and all their systems are in the cloud. So it makes a perfect and natural sense for them to use our cloud platform. So they just go directly to cloud. And over time, they grow their needs and they max out, and then they want more cloud. That's all good. We can handle. It's a pretty scalable cloud. We manage it ourselves, unlike some of the other vendors who don't own their own cloud. So it's depends on your use case. Some companies actually they also move directly to enterprise. So we have seen some of our larger customers, they test the OSS, but they never put it into production. They look at the security and some of the other enhancements that we have in the enterprise version. So they jump straight over to the enterprise.
Fantastic. And as you mentioned early on, Kubernetes is kind of the thing out there today. Elizabeth asked if you could restate how is Influx being used to monitor Kubernetes and the applications running there? What specifically are they monitoring?
Yeah, so let me go back to the slide, I think. So Elizabeth, thanks for your question. If you are looking at my slides, let me just bring up the slide here. So this is the Kubernetes. On the left-hand side, we have the Kubernetes master. And on the right-hand side, we have a node, which then is hosting 2 pods. And those dark gray boxes inside the pods are application or applications. You can pick. And these applications could be deployed on Docker as well. So Kubernetes, in this case, let's say is running Docker, and there are a bunch of applications deployed on the Docker. Now you can do many things. You can monitor the Kubernetes nodes, pods, or application with Influx Data. Now the way you deploy it is depends on your needs. We provide 2 ways to deploy our Telegraph agent or plugin. So Telegraph can be deployed as a daemon set. So as a daemon set, it is really easy to deploy Telegraph. For a sidecar deployment, it is slightly more difficult because sidecar then has to be configured based on which application parameters you want Telegraph to read. So your question was, how can we monitor and what can we do? So we can monitor everything. Every piece of application architecture that is deployed on Kubernetes can be monitored. The application itself can be monitored. There are two types of application details that you want to monitor. One is the application health. The other one is application usage. How many users are using the application right now? Which part of the application they're using? What is the response time? And what are they buying? Which pages are they on? How many, what is the average time spending they're spending on the page? So those kind of metrics can be read by the sidecar. The health metrics can be read by daemon set, and by that I mean the health of your master and your nodes. So essentially, we can monitor the application health, application stats, Docker health, Docker stats, Kubernetes health, and Kubernetes stats. So we can do 100% of monitoring when it comes to Kubernetes.
Fantastic, thank you.
Yeah, and sorry, just to add one more thing. And we monitor both Kubernetes and non-Kubernetes, right? So Prometheus works out really well for Kubernetes pull style, although it doesn't give you long-term storage and high availability. We give you all that. We monitor 100% Kubernetes with long-term storage, with high availability, with security. And then additionally, when it comes to non-Kubernetes, we do that as well. So truly full stack monitoring.
Fantastic. Great. So Sarah D asks, what sort of infrastructure does an organization need to plan for to support the TIC stack?
So if you want to try out the cloud and you eventually adopt our cloud, you don't need any infrastructure. And if you want to try out OSS and you want to try out the enterprise version, it depends on, you will need to do sizing based on how much data you're pumping in. If it is just a trial, I can run Influx on my laptop. So in all components of the tech stack can easily run on any laptop. And one basic demo that we usually do is just install it quickly and read your system stats. So that is, it is a few hundred megs. It is very small binary. You can quickly deploy it. But let's say you are reading millions of points, then you will need a good software, a good server to run the software, and you can size it depending on how much data you're pumping through. And if you go to our docs, we have pretty detailed sizing there as well. And our docs are pretty extensive, and part of the documentation is under the OSS docs, you will find the sizing docs as well.
Great. We have a lot of great questions coming in, actually, and more than we're probably going to get to because we're probably only going to have one or two. So the Influx team will get back to you with some of these very specific technical questions. But this one points back to a previous slide as well, and really the types of data you can store, time-based or data streams. So SumSwar asks, what sort of data does it have to be only time-based? What sort of data can you store into Influx?
Yeah, it is all timestamp data. Timestamp data is emitted by sensors, machines, automotives. So any data that has a timestamp on it can be stored in. So you can also even store customer orders. If you are just monitoring, let's say you have a huge e-commerce presence, right? And you get millions of orders every hour. You want to just put a timestamp and store the number of orders and show a plot on how many orders you have received in the last 24 hours versus how many orders you received last Wednesday. You can do that as well. So anything with a timestamp on it becomes a time series data for us, and we can store it and process it.
Great. And is there any sort of, so Daniel F is asking, is there any sort of, are you able to support like high performing applications, larger amounts of data? What's the kind of scale that people can expect?
So our goal is to be the most performant time series platform in the world. So with that, we can, I cannot go into a lot of details of, because some of our customers are some of the large financial companies in the world who process a lot of payments. So I cannot go into a lot of detail there, but all I can say is sky is the limit. So if you want to, push in 1 million points into our platform per second, or even less than a second, we can handle that. We are the most performant time series platform out there. And the reason is we are purpose built for time series. We don't do anything else. So we don't store JSON objects or multimedia files in our database. Our database is tuned to do only time series. So there are no limits to how much data you can push. You will just need to size it, and we'll be able to and happy to support any of your requirements.
Fantastic. Well, it is near the end and it's giveaway time. Before I read the names, I want to make sure everybody knows that this webinar was recorded and you will receive an email in the next few days with that. Make sure you share it with your colleagues and pass the word about the challenges around monitoring monitored applications and how Influx can help. Navdeep, thank you so much for your presentation. I think this is very useful and extremely important as organizations embrace modern development. So I'm going to go ahead and read the names of the giveaway, and each of you will be contacted after the webinar via the email address that you registered with, and we'll let you know how to get access to those $50 Amazon cards. All right, so starting with the first winner. The first winner is Anamika M. Congratulations. And the next winner is Andy A. Winner number 3 is going to be Charlene B. Winner number 4 is Eric Y. And finally, the last winner of the $50 Amazon gift card giveaway is Rudy W. So congratulations to all of you. We will be sending you an email for you to collect those gift cards. And again, Navdeep, thank you to you and Influx Data for this wonderful topic. And make sure everybody go and give Influx a try today with their trial software.
Thank you, Chris.
Yeah, thank you, and thank you for all the attendees.